Alright, another draft physics video presentation. The first part will be a response video to Franklin Hu of the CPS whatever thing. The Saturday chat. He did respond 2 weeks later to the conversation on polarization and then kind of just changed the subject. But anyway, not dealing with the points raised, but it doesn't matter. Take what we can get. So in a way, he says we agree about a lot of things. I suppose some of that's true. It's mechanical. Whatever the explanation is, should be able to draw a picture of it. We might be able to agree on that. But fundamentally, he finds the idea of moving particles, I guess, and to some extent, inconceivable clumps. It needs a medium. Somehow there has to be water for the things to travel through. I would still argue that even if I put the water in there, they still look like torpedoes. Okay, they don't look like waves. So it just doesn't make any sense to me. I mean, if I have torpedoes, why would I bother, torpedoes that don't care about the medium? Why would I bother with the water? Just superfluous to my purposes. So I don't know if this is overcomable in terms of these conversations between people. I mean, we're really just talking about if we could agree on the fact that momentum moves from one place to another place, and that it does it in the case of photons and other forms of energy moving the speed of light, it does it incredibly efficiently. That is, somehow none of it's lost anywhere, fundamentally, unless it hits something. Clearly, and then it's not lost, it's in the something, and the something eventually gives it back in the sense that everything reaches some sort of equilibrium state where everything that comes in eventually comes out. So I guess we could draw a little bit. I'll try to just stay on the points that need addressing, which some of them were on the subject of polarization that I think, it's just my opinion. I mean, you gotta take this stuff kind of a step at a time. And if you keep changing the goalposts, so to speak, you keep changing the game you're playing, you never play any game very well. And that's part of the problem with dissidents, is that they're too superficial or too specific. They make specific claims, and they make very superficial proofs of the claims, one could argue. So the competing theories are something to do with this idea of the universe runs on, there's some points in space, and I would say that the competing theories are, I know it arrives at point B. Okay, this is point A, and that the momentum goes from point A to point B, and it does so in this way that's just so efficient. I mean, it's just dead efficient, and these are dead small locations. So to me, it just makes sense that something travels this distance and gets it to point A, and it's carrying something called momentum. Now, their theory is that this thing somehow is waving, and the rules of their wave is that it's not really going this way, the wave, and it's not really going this way, that somehow the wave is being kept to going this way and waving. Okay, but yeah, how's it doing that exactly? Waves do tend to do this thing where any disturbance of the medium disturbs it this way and this way and this way and this way and this way. You can't poke the water without that happening, this whole big thing. And this doesn't really have anything to do with getting to point B efficiently with the energy, because you would be wasting a bunch of energy going in all these other directions that never land somehow. They never hit the shore. So Franklin would say, yes, it's like this. It's a laser wave or something. But I would argue that, well, it would have to be so minuscule in terms of its dimensionality, because we know that photons fit in a tiny, tiny box, and so it just has no depth, no height at all. It might as well be smaller than an electron, smaller than a neutrino or whatever. And so he speculates that there's some sort of sea of neutrinos and, I don't know, positrons and electrons or something, and somehow they're arranged in some arrangement that allows you to get from point A's to point B's always the same, no matter which direction I go in. I mean, obviously in this drawing, this direction is going to be very different than this diagonal direction. The distances are going to be different, and it's not going to be the same point A to point B, the same travel distance. And if I randomize these spots, well, then I got the problem of it's going to have to pass its energy and all kinds of herky-jerkiness, and how can it land at point B with any kind of precision? I mean, how could a photon go billions of light years across the universe if it has to do it with all this stuff going on, and get and arrive making a consistent image where all the point A's and the point C to D and E to F and all of them line up the right way, and you get a coherent image? I mean, how is that possible? Doesn't make any sense to me. And again, I would just say that this theory of ether, if you're going to particularize it, if you're going to say the ether is, see, I don't know, some people, like Ken Wheeler's, I don't know whether they think it like one spot in the ether gets really big, okay, but if it got really big, it would push in all these other spots. You know, I mean, how does this happen? And so if you have a particle theory of ether, well, then you're still stuck with, there's two particles and one of them bangs into the other and replaces it. So A particle bangs into B, and A particle stays here, and B particle goes here and bangs into C. You know, and then B replaces it. And so you have some cascading particle. Aren't you still moving particles? Aren't you? What's the difference? Why don't I just get rid of all this crap in the way and just let A jump all the way to whatever, Z? What's the point of all this crap stuff? I mean, nonsense. Now, the only evidence for this wave stuff, just as he points out, there's no, see, at least he says this idea that this is two waves, you know, that it's waving in and out, you know, this way, and it's waving up and down. Well, he says all that stuff is crap, and all it's really doing is banging into bits, you know, in a row, cue balls. You hit one cue ball, the rest of the cue balls hit, and one cue ball pops out at the end. That's sort of his concept of this ether. But like I said, they all have a different concept. Whatever they're imagining, I'm imagining it just being way too complicated, way too much structure. You just don't need it. This is so he says he finds it inconceivable, these clumps, and yet, you know, you have a universe where you see it all the time. I mean, comets, asteroids crash into things. I mean, it happens all the time in the real universe, you know. It happens on this planet all the time. I mean, asteroid showers and whatnot. Don't need any medium for that to take place. So what other point did I want to make? So anyway, just this creates this, you know, this bad foundation. I mean, trying to put this square peg in the round hole that I see doesn't work for me. And somehow this simple notion that there's stuff in the universe that move in the speed of light, a constant speed. Also, you'd lose the constant speed if you could imagine this randomness. There would be, that this would increase distances, you know, randomly, and you'd end up with photons moving different speeds. Then you'd be screwing up the phase of your wave. Clearly, I'm arguing waves are emergent. They're not something fundamental or elemental. And if you make an elemental structure, I'm arguing that you can't make one that's as powerful as the straight line. This straight line can go any vector, you know, and it does it precisely. It gets to any point precisely. It doesn't get screwed up by the irregularities of the matrix that you're running it through. The medium doesn't provide any obstacle, and I'm just saying it's kind of obvious, in my opinion, from the fact that we can see things billions of light years away perfectly clearly, you know, with the right technology, is an indication that there's nothing in their way. That's how the photon got here, so it just didn't hit anything. Anything that significantly altered its path anyway. So I can't get his square peg in any kind of rational whole, and he somehow can't get this concept into an understanding of how this can create waves. And this to me, I kind of obviously waves are emergent. So if I create a mechanism, if I just shoot these at a frequency, I've clearly got the essence of a wave. I got the first the idea of it is there just in frequency. I don't need to spread it in any dimensions. I don't have to give it any nonsense. So I sort of made an argument that the polarization sort of illustrates this point, because in my model, in a independent particle model, not a ether particle model, what polarization could merely be is that the emitter is moving as it's emitting the light. So this is an electron, it's moving. It's never stationary. So it fires the light, that is, it releases it a little bit out of positions. And that's its polarization. And a polarizing filter, because they're basically transparent, has two levels to it. It has two types to it. It has these bars, you could argue, that create an extra phase shift. And so this is just a half phase shift. This is another half. And so on top of it, so this would be a full phase shift. So all that's happening really is when the light goes through the filter, some bits get hit the nonsense, end up out of phase. So they end up here instead of there. So all the energy of the photon is still there, and it's recoverable, which kind of is an explanation for the 3 filter experiment, in the sense that all you do is recover the phase, change the phase of the other bits that were in the other alignment, and you end up with a photon again. You end up with the right sequence of events. And the reason why this frequency even means anything just has to do with the fact that the electron is bound in an atom, and it doesn't move freely. And so if it does move somewhere, it'll tend to move back again. And so the energy goes in to move it, and then when it moves back, it releases the energy again. And that's basically the function of electrons. And they can give back the energy by changing the frequency or changing phase or doing a lot of different things. And that's why we have slit experiments and whatnot. All right, so that was the polarization argument. Getting back to the more fundamental argument, I'll see if there's anything else I have to say on this idea that we're required to think in terms of waves for some reason. So I'm saying there's no evidence of it. He brought up oscilloscopes and the fact that oscilloscopes show you this, which doesn't mean anything, because the oscilloscope is creating that for your pleasure more than its actual evidence of what actually went into the oscilloscope. And remember, our detection means also change what the energy could look like especially when you convert photons into electricity. Well, then the electricity is in the form of atoms communicating with each other, and that is essentially a medium. So electricity is going to end up being a different form of our expression of the momentum than the actual momentum that went in. All right. So you can't imagine clumps. Velocity is an interesting subject, as pointed out, because I'm giving this little particle this speed, and I'm just saying it's elemental, that the little particles of photonic type energies, gravity, magnetism, they move the speed of light, and that's it. That's just the rule. They're all the same. They're all moving, and it's elemental. You have to go back to some creation story to explain why it works that way. But everything else that has velocity has it in some complex way, where the electron, it can be observed, does in fact drag to a halt. So as it moves into a field, it's hitting more ether, you could argue, or I would argue it's going to hit more of these elemental particles moving towards it than moving with it as it moves in a direction. And it will be dragged to a halt by that process of absorbing more energy in one direction than the other. The force essentially is dictating where this electron goes. And then you have bigger, so this can't maintain a velocity for very long, just short periods. So you have to keep accelerating electrons to keep them moving. They won't just get trapped. There's no such thing as an electron trap somewhere where you can just watch electrons they trapped 100 years ago and you can watch them still spinning around in a perfect magnetic field. Theoretically, it's possible, but you can't make the electrons do it. And the other argument he made was and then bigger clumps of matter, nuclei, can become cosmic rays. As a proton, we'll just put an X on that one. And as I pointed out, that's because it has to have a mechanism inside to trap energy in a direction to be able to maintain its velocity. And so big matter can create a trap. It can keep gaining velocity, and it will keep it. It has a little motor against the force coming in. So there's extra force hitting it in the direction, but it has an extra force inside of it that's permanent until it's destroyed, the complexity of the matter. And so it has enough energy to overcome, built inside of it. It has a one-way pusher built out of electrons and protons. So that's more detail than you need. So anyway, his argument is this stuff has to hit each other. Like waves can go through each other, so you can have two waves. And I don't think they do this very perfectly, but anyway, that one wave can go this way and one wave can go this way and then go right through each other, and you don't cause any real hard problem. I would argue that if you make this thing out of particles, then you still have to explain how the individual particles do that, how they don't get messed up. Because, if you try it with cue balls, putting two kinds of energy in at the same time, you're going to get a mess. Okay, so once you particularize your gravity, your ether, you got the same problem in terms of explaining how they don't bang into each other and destroy the energy. So you can draw waves and say waves go through each other, but if you make the waves out of particles, you're going to have a hard time doing that, in my opinion, because of the two directions. You're adding up two directions at a time, and the particles are going to end up doing whatever the net velocity is, the net momentum. Momentum's a key word too. Arguing for the idea that this is a massless particle or something. It's only massless even in the mathematics when it's at rest, and photons are never at rest, so obviously they don't have a zero rest mass, because they're never zero. They're never at rest. So they always have a mass, just mathematically, because they always have a velocity, and so they have a mass. Anyway, so what else is there? There's the So why don't these particles hit each other? All right, so I've made this argument 4,000 times, but I'll make it one more time. So in this perfect universe, it's even better than a pool table. A pool table you can kind of do this if you hit it just right. But you can hit a ball that's going, a ball can go going this way slow, and this one you can hit really fast into it. And what you'll get out is this ball, little X ball, will end up going the direction that this ball was going, and this ball will end up going this way, the way this one was going. And that's, real good kinetics. Pure kinetics will get you those kind of reactions, like the Newton's cradle kind of thing. So, in a sense, there's no difference than if I miss the ball, one ball ends up here and one ball ends up here, right? If I totally miss, I have two things sitting there, because this one just goes about its way and this one goes about its way. And if they hit each other, I end up with the same thing. There's no difference. So, I've drawn this hundreds of times, but if, I have two things hit each other and they reflect, the universe will look like this, when they're done. And if they miss, the universe will look like this when they're done. I mean, there won't be any difference in the universe. So even if they do hit each other, you could never see it. Now, my only counter to that, specific to my theory, is that I have a theory where there's two kinds of colors to the force. There's two types, proton and electron. So obviously there has to be a reason why, obviously if they have two different colors, you could see, not obviously, but I guess I'll make the point, you could see the difference, because the black one will end up going this way and the red one will end up going this way, and that won't look the same, okay, as the miss. The miss will have the red one going that way and the black one going that way. So the two universes won't look the same if they have different colors. My argument would be is that these red ones and these black ones are actually on different layers of the universe, so they can never really interact in free space. And the electron and the proton, that's why there's only a deflection. So a proton gets hit by a black piece of energy and it basically just deflects it. It doesn't make an exchange. It doesn't gain any momentum, because it's not on the right level, the right layer of the universe. So you take the universe and you just cut it into, lines, and you just say these lines are parallel to each other in all three dimensions. So, the black stuff's running a little bit below the red stuff, and and you just do that in all three dimensions. It works out fine. You just basically cut the universe into two, and 50% of it's on the red rail and 50% is on the black rails, kind of thing. The two aren't on the same plane. So anyway, but that would explain why the forces never interact, but they can still interact with the matter bits. Anyway, alright, so that's probably enough of the Franklin stuff, and I'll do some comments. I mean, there's enough of a subjects there. So like I said, saying we agree just doesn't go anywhere, in terms of, but fundamentally we don't agree. And we're still stuck with a bunch of, square pegs in round holes. And that ain't going to work. We really have to go with the evidence, and I'm just arguing. You have to argue from the experiments that exist and rational interpretations of them. Franklin tends to believe all this crap of all these neutrinos and positrons and all this crap as being something we really know for sure exists, when I would argue that all we know is that there's a clump of energy that hits something, and the fact that we've called that a particle, I would argue is a mistake. So I would argue that if you do get a proton up to high speed, that it could look, it's just going to be a bunch of, once it's going really fast, it's just a bunch of, red stuff going that way. And certainly when it lands, it could land looking like a proton, but it's not going to act as a charged entity to anything but something it hits. It has to hit something for the charge of it to be recognized. It doesn't have any charge while it's moving through the free space. Once you've converted a proton into energy, it's not the same thing. Exactly. It's only the same thing when it lands. So it's like you lose your spaceship. It's like if I had a spaceship and I made it go really fast and it broke into a bunch of pieces. The pieces still have the same momentum, and in some sense they have some of the same capabilities, but it's really not the same as the whole spaceship. Not the same functionality. All right, I think that's... The other points on polarization that I think are important are, it's listed. The idea that you're just changing the phase could be hugely important, could be detected by how much energy you actually can demonstrate to be caught or trapped by the filter. How hot does the filter get? What does the filter radiate? Does it reflect any infrared or ultraviolet or some other spectrum energy? Or is the energy in it and it's, somehow, there's just no experiments where they bother to do that, at least I know of. And I think it's hugely important in terms of understanding whether this thing is absorbing photons or merely breaking photons. And then the antenna polarization thing is really important to understand that polarization can be created by different aspects, in the sense that there's the antenna, and then there's the shape of the electrons inside the antenna in terms of what they're doing. So the electrons are doing something like an antenna in the sense that they're moving, jittering, probably in one dimension more than the other. And the antenna itself has a shape. And those things are two different kinds of polarization, although they have a similar physical consequence. It's not the same thing. Yeah. All right. So, on to the regular video and such, so forth and whatnot. Yeah, so probably enough. Probably. Ew, I don't know what that happened there. I don't want these filter. Thank you. But yeah, it would be the same as my regular comments for sure. Alright, so what is this? There's only 4 comments listed. I hate YouTube. I mean, everything they change, they just break. It's just terrible. Yeah, they give me 3 comments. I don't know why. Why is it? I mean, it must be the ones on the video. I just want the comments. Thank you. Without a filter. Still not the comments. I mean, what do you have to do to get this thing to work? You know, the way it's supposed to. Alright, so there's still some, I mean, these probably aren't important comments, but I just mean, this is stupid. How do I get it to work? I want all the comments. Thank you. What is this? Drafts. I don't know what that even means. Okay. And this thing is, what's all this? What's all that crap? Stop it. Turn it off. Doesn't turn on. Oh, that's the star thing. I ain't gonna turn it. Where's the stop button? There's no stop button. It's just too stupid. God, I hate this shit. YouTube. Google. Evil bastards. Alright, there we go. Alright, here we go. Time to, nothing works like that. Okay, so we already did that. I don't understand your time dilation analogy at the beginning of this video. If it is assumed that all things in the universe are reduced to bits rather than contemporary standard model physics concepts, yes, well, I'm just saying, yeah, obviously, I don't know what good it does you just assume, I'm giving you a very simple model, yes. Mechanical straight lines, yes. Wouldn't time dilation need to be explained in some way by nuclear level impact of some kind? No, because it doesn't happen on the nuclear level. I mean, as pointed out, the whole argument is there's no such thing as time dilation. There's just broken clocks. There's just changed something that's happening inside of something. Now, an atomic clock is a kind of clock. Okay, the rate at which an atom degrades and falls apart is a thing that happens at a certain rate, and you can change the rate at which that happens. Now, I can change the rate just by making this stuff hot or cold. Alright, that's the simple truth. You want to break an atomic clock, you can just make it too hot or make it too cold. Put more of the atomic stuff next to it, okay, and cause more deterioration. The stuff will, in fact, lose its radiation quicker the more contact it has with other radioactive substances. So I can break an atomic clock in lots of ways, and one of the arguments is that one of the ways you break it is with velocity. The fundamental argument, Einstein's, the whole point is that Einstein's already admitting the truth, because he's basically saying light, okay, the fact that you can move a photon back and forth, okay, between two surfaces, That's a light clock. And that clock never breaks. And no matter where I take that clock in the universe, that clock is always consistent. This always moves the speed of light, no matter where I go. And so in a sense, that clock is telling me reality. And as Einstein pointed out, in a sense, if I have a rocket ship, all right, and I move it, accelerate it, the light will bend down. Appear to. Merely because it went straight and the wall of the ship moved. So as it was going here, in a nice straight line, the wall of the ship moved up, and now it looks like it hit this part of the ship. Well, it did hit that part of the ship, but that part of the ship moved to where the light is. So the light moved a perfectly straight line. So that clock can't be broken. That's the only clock that can't be broken. And the rest of it's just broken clocks. Some mechanism that we use to tell time that isn't as direct as this, that is more complex a system. And as I pointed out, a processing circle will sort of give you the clue to the idea that if you process a circle, the distance you have to move, that is the circumference of the circle, increases, which means the faster you move the procession, the slower number, the fewer number of actual circles you get, because the circles are getting bigger. So I'm sorry to be patronizing, but I mean, I sort of went over this. So on the nuclear level, the subatomic level, there's no clocks to break. You can't break the fundamental player, the photon, and its speed. You can't break this. Okay, but all these other relationships between electrons and protons and how they're moving about and jiggling and doing whatever they're doing, that you can break. Right. Sorry, but I've just been over it. Alright, so Superior Mind, I think, handles it appropriately. Let's see what he says. I'm not sure what you're referring to by nuclear level impact, but it does start at the nuclear level. The forces that make up the mechanism of matter have to travel much farther and much farther for faster motion. Well, the point is you can't move it, okay, without changing, because it's already moving. You know, it's already moving. You move it somewhere else, it's got to account for the extra motion. That means it has to account for the extra distance. And it can only move one speed, so it's obviously not going to be able to do what it was doing before at the same speed if it has to do something else. So it's simply taken care of by the multitasking argument. If I give it another task to do, which is to move through space, that extra task is going to have to be taken out of the time it was doing other things. And so it takes matter longer to do anything because those forces are still the same speed. You can't change the speed of light. It's like shifting gears in a sense. Well, it's not really, but good enough. All right. I appreciate your efforts. I'm not an academic physics student, but I like physics and the simplicity of your model. Yes, it's simple and it actually works is the more important part. It actually explains how a magnet works. You may have been asked this before. Would you consider writing a book? So again, I mean, even in this video, I think I pointed out that, well, if I give you basic definitions, isn't this basically a book? You know, I'm basically telling you this is what an electron is, this is what a proton is, this is what a photon is. Aren't we almost done? But anyway, in the future, or working on one already, maybe. I'm sure a little crowd fund could help the production. Yeah, well, like that works in the real world. Okay, only thing popular stuff gets funded. This is a popularity contest. So until I'm somewhere in the, stream of notice, it doesn't do me any good to do any of that crap. I have been watching you for a bit now. I do not want to see all your hard work fade away. So this is another bizarre notion in a way. That somehow I could drop dead tomorrow and then everything I said is gone from the universe. When, no, videos are still here. I actually have an archive separate from YouTube where everything is. So I don't even have to, somebody else takes care of that. But I'm just saying it's not going anywhere. is all just as good as it's frankly as good as a book in the sense that it's pretty durable. So it ain't gonna fade anywhere. Keep it up, sir. Well, whatever. Take a bunch of notes. Boom, you've got a book. Well, pretty much. But I mean, this channel is called Draft, so I mean, a lot of it is still imperfect, and so it's hard. You really don't want to write a book until you really got it all nailed down. But I don't want to imply that it has anywhere near the holes that all the other loopy theories have, because clearly it doesn't have those holes. And it actually explains magnetism, which nobody does rationally. Nobody. I mean, Bill Gates got some jumping rope theory. The deholsters have this stupid, look at what happens in water when you put, when you put 6 horsepower in, you get 1 milliwatt of movement energy out. Yeah. Oh, yeah, that's a great explanation. No, stupid. And I would argue that you can't make any sense of Ken Wheeler's thing at all. A bunch of toroids and hyperboloids. How does that create attraction or repulsion? Just no explanation. Anyway, nice video. Your gravity explanation makes perfect sense to me. Well, then you shouldn't need to comment all this crap. But I'm still not fully understanding the magnetism stuff. Well, that's the obvious and easy stuff. I mean, that one's simple. Anyway, you see there are 2 types of force bits. Well, yes. And the interaction is different. Yes, exactly inverted, which is what's necessary. You need an inverted reaction. Somehow protons behave exactly the opposite of electrons. Alright, the black force bit going into the black electron will be mirrored back out, while the red force is going into a black electron. No. Will somehow be deflected a different way. Yes, it will. It's going to be deflected. It won't be reflected. Yes, it's not going to go in the boat, exchange, okay? It's not going to take a seat in the boat. The people in the boat basically say, you're the wrong color. I mean, it's really politically incorrect, and they just say, fuck you, get out of the boat. White only, black only, that kind of thing. Cruel, but that's the way the universe works. Alright, okay, I guess I still need some explanation about how this black versus red deflection works. Well, how it works, why it works. I mean, really, you want the creation story. Well, I can't tell you that. I'm just telling you the rules, like Newton would say. I'm giving you a rule that explains why it works the way it works, and why there's an inverse square law, and why it all fits. Okay, I mean, that's all I can do. I can't tell you this is how the universe was created. So, I mean, I've given you such simple rules. 2 kinds of force, 2 kinds of matter, and, boats, and 2 kinds of interactions. I can't do better than that. I don't think. It seems the black force bits all like to be in the same place. No, they don't. But inside the boat, yes. The boat is bigoted. It's white only, black only. Red only, black only. An electron. And the red force bits also like to gather in the same boat, so to speak, i.e. a proton. Again, you're taking the analogy further than I have any interest in going. Okay? I mean, the analogy works perfectly to explain exchange, and to explain why the boat moves much slower than the force bits that jump in. One rower jumping in the boat can't, own the boat and decide the boat goes the speed of light. Because I was going the speed of light, I get in the boat, I'm rowing, and I'm not rowing against anybody else. So of course, I'm still rowing against all the other rowers in the boat. I'd like to know why these gatherings are so binary. Well, then too bad. I mean, you're never going to be satisfied with any theory ever proposed. You could ask the same questions of, conventional physics, again, doesn't even say anything. They don't explain what a virtual photon is, let alone explain how it does repulsion 1 minute and attraction the next minute. It's that vacuous and empty a theory, and here you are sitting there saying, I have to tell you so much more. I shouldn't have to. I already have told you so much more than they have, and you want the creation story. Well, I don't have that. Like why protons like to be mostly red and electrons like to be mostly black. Well, they're not mostly, they're entirely, is the whole argument, but whatever. You know, that's the rule. There's only 6 things, 2 plus 2 plus 2. And you're saying, oh, those are too many elemental functions. I can't accept it. You know, give me the one thing that happened. Give me God's finger going poof to the universe and creating the rules. Well, I can't do that. And we don't really see anything in between. Do the red and black force bits just pass through each other when they collide? Well, in the field, the argument is they either are transparent to each other. They could be so tiny, you know, theoretically, you could just make them smaller and smaller and smaller. Because all they have to do is, the only time we see them is when they hit an electron. So I could have a BB in space, and I could hit the Earth with it. All right? Or I could have something the size of the moon, and I could hit the Earth with it. If I gave that thing the same mass, you'd understand that it wouldn't matter. So all I'm saying is photons could be so tiny that they never hit each other in free space just because they're so damn small. They could be that level of tiny, and they just carry this one little clump of momentum. So there's lots of explanations for this collide argument. The fact is, light doesn't crash into light. It's just the truth. And all the other forces behave the same way. Gravity doesn't crash into gravity. You have to it has to get to the matter before it can have an effect. Forces can't have an effect until they actually hit a material object. And that's just the rule. And they don't interfere with each other. Magnetism doesn't affect photons. You can't make electricity do it. You can't bend photons with a force. You have to bend them by throwing electrons in their way. While the red on the red or the black on the black actually exchange momentum, they don't exchange it. The boat exchanges it. There's only a certain number of seats in the boat. When you jump in the boat, you kick out somebody swimming the opposite way you are. I mean, it's not a complex analogy. That could be a decent explanation to me. I don't even know how that was an explanation. Again, you can sit there and say, okay, let's take it a step even lower and say what's really happening. What is an electron really? And I could argue that an electron and a proton are really just patterns that are trapped, so that there is no boat really. There's just the pattern. And the pattern, okay, can go, stuff moves in, stuff moves out, but the pattern's durable to, effects from the outside, because the inside of the pattern, like the inside of the Earth, is hard to get to. I can't knock on the Earth and expect the vibration to make it to the center of the Earth. It just won't get there. Just like the hot molten stuff in the center of the Earth, the heat can't get out. All right, it ends up being bent and turned and swirled back in again, and it just, they say that the photons we see from the sun are 1 million years old, that the photons really got created a long time ago, and they're just having such a hard time getting the fuck out of the sun. The heat is just having a hard time getting to the surface and getting free. So I can make that physical argument that there is no real membrane. There's just a pattern, and the pattern's now of a size where the outside universe can't really break the pattern. So that's what a photon is. That's what the electron is. Sorry, I don't mean to make a confusion. That's what the boat is. The boat is just a pattern, and it's a big enough size that it survives most of the random impacts. And it would take a tremendous amount of energy in one direction to wipe out the pattern, to erase it. But that's a level. You go that level deeper, it might satisfy somebody like a Hoffler day, but to the average person listening, they're not going to really get what I'm talking about, in the sense of it kind of an argument where you're particularizing the entire universe into locations and doing kind of a field theory. Now, I guess I'm not opposed to it, but I just don't think it's conducive to understanding the overall concept. That the concept of the simple 2 plus 2 plus 2 satisfies everything you need as pieces to explain phenomenon. And that's all I really want to get done here, is to prove that this theory explains it, that it all works, the pieces all fall together. Magnetism is understandable. Here you're saying you don't understand, and yet the drawing is so obvious. I mean, how can you not understand? There's two simple rules. I already drew the two simple rules, and it creates a filter. So the magnet just filters what comes in. It reflects all the black energy, and all the black energy that hits the red end ends up coming out the black end. So now you've segregated the two forces. And now, if you put a charge somewhere around it, you're going to be able to detect the fact that these two objects are radiating opposite forces. And that's the nature of the dipole. Oh, well, whatever. I don't know if it's helpful, that's all, to try to force more, to make it even more complex physics in terms of taking that step deeper. Into trying to define the distinction between a electron as a particle and an electron as a pattern, because they could be argued to be the same thing. So the field energy or force that is traveling through space gets filtered and sent back out in a manner where the protons and electrons within it are grouped according to their kind. Well, that's the consequence. Yes, I've said it so many ways. It's segregated. Okay, so this was a response to a Miles Mathis video of some kind. And the point is it works. It explains why. It creates a mechanism that allows you to have intense attraction and intense repulsion between electrons and protons. It explains why they repel and why they attract. Alright, wise monkey, flawless. And then he puts that dude in there. Just for fun. Ha ha ha. Just more evidence of the idiocracy taking over. This has to be thrown in for fun, and we have a smiley face. But anyway, it wasn't exactly flawless, but it was a damn good video. So anyway. All you have to do is, like I said, you define these basic functions. So I'm going to do waves and rays and try to define the differences. And the biggest difference is this wave spread, because waves are emergent. Waves are really a whole collection of rays. That's how you make a round wave. That's how it really works in the physical universe, in the sense that when sound goes through the atmosphere, or when water waves wave, there's actual physical particles that are moving in a direction. They're piling on top of each other. There's two particles here. One particle tries to jump into the space of the other particle, and it says, I can't take this guy. You can't put another atom here. We can't have two atoms in the same space. And so the other one has to get kicked out, and it moves into, and it piles on top of another guy. So it's just really, musical chairs. You got too few people and too many chairs, you have the idea of a wave. Anyway. Oh, there's another one. What's a photon? LOL. So this is I don't know. People who don't believe in a photon, they don't believe in momentum, traveling the speed of light, going from one place to another at a frequency. I don't know. I don't think that's all that preposterous. But anyway. Till the next time and such, so forth and whatnot. I guess that's enough. Yeah, well, that's enough. I declare it so. Let it be done and all that kind of crap. Make it happen. Blah, blah, blah. Some kind of whatever. Star Trek phase. They always had something to say. Yeah. Just do it. It really was that bad. Anyway, till the next time. I really think that's all necessary.